Yeah, I'm sharing my screen. One second. Mm, Sequential circuit design using CMOS. Yeah. My screen is visible, no?
Yes.
Okay. So here, today we'll discuss about how to design this CMOS SR latch using NOR gate. Okay, CMOS SR latch by using NOR gate. Okay. Yeah.
Uh,
Yeah. You are asking something?
uh,
Yeah.
Sir, yesterday I asked one doubt, no sir.
Which one?
Previous task, second one.
Oh, oh, oh. Okay.
But answer I not get, sir.
Yes, diagram I was asking.
Yes, sir.
Diagram. Okay. What did you explain? What did you explain?
A, A plus A into B plus C plus D, sir.
A
Expression
plus A plus
AB, AB
AB
plus,
A plus
no sir,
AB.
into C, into AB into C plus D.
One second. Oh, okay. Yeah, yeah. I given one diagram, no? What about remaining? You got
Yes, sir.
this one. What about remaining?
No, sir. This one I didn't got.
Okay, you didn't got them. Okay. Here AB. So first is you are getting AB, AB and A plus AB, no? A plus A plus
Plus AB,
AB
C plus
AB
D.
C plus D. Okay, C plus D. C plus D. Okay, this is my expression. Uh, so you know that for R operation, for AND operation, tell me PMOS will be parallel or series? Parallel. Okay,
Parallel.
and NMOS will be
Series.
series. Okay, and next for R operation, PMOS will be series
Series.
and NMOS will be parallel. Okay, NMOS will be parallel. Okay, so here first so in the PMOS, R operation means series means first this is VDD, this is VDD, and first A is there, no? So A means mm, so this is A means this is A, okay? This is A, this is PMOS, and series, no? Here R operation means what? Series you will get, okay?
Series.
So this is series, and here AB means what? Again, these two, you can say these two are parallel. Okay, so these two are parallel. AB is parallel. Let us take this one A and B. A and B. This is parallel. Okay, parallel. Mm, parallel. So this one is A and this one is B. Okay, B. So AB, okay, this is AB. Again, AB parallel. Again, AND operation. AND operation means what? Again, with this parallel, no? Why?
Yes, sir.
Because this is
And
AND
most
operation.
parallel.
This
Mhm.
is parallel. Parallel. CRD is nothing but what? Series. CRD is nothing but what? Series. Okay. So series. So two more transistors. This is PMOS and PMOS. So this is C and D, and these two are connected like this. You got the first
Sir,
expression in the PMOS?
sir, we can do this, but my doubt is there any possibility of minimization of this equation?
What you are asking? Is it possible to
Is there any possibility of minimization, sir, about the
minimization?
equation?
Minimization means, suppose if you want to minimize, here you are getting A plus ABC plus ABD. Okay. If you take A common, what you are getting 1 plus BC plus BC plus BD. Okay. That means A. 1 plus something is what? 1, no? 1 plus something is
But
what? 1. So this is A means. So you are getting only A means. How you are defining? Like this also you can do. So this is nothing but one inverter and one more inverter. This is nothing but buffer, no?
yes, sir.
A and this is A bar and this is A bar whole bar equal to what? A, no?
Yes.
So two inverters connected cascade. That is, if it is connected cascade, you are getting A. Like this also you can do. Understood? Is it clear? Shall I move forward? I think this one you do know. You can do know. Two inverters connected.
Sir, yes, sir.
Two inverters. So first one inverter. What is the first one
Sir, if
inverter? Yeah, tell me. First one inverter. So
sir,
this is
if the PN by using CMOS with this whole equation,
uh,
what output we may get? Sir? Same A only
same A
or
only will
something
get.
else?
Same A only will get. Same A only. You see the different
Then
possible combinations.
we can use two inverters, no, sir.
Yeah.
Better to use, no, sir.
Yeah, means you minimized means you are getting A means. So it means you need to see for minimum possible circuits. That only we are doing in the Boolean algebra. No, we are minimizing that circuit. So you take some different possible combinations. Suppose A equal to 0 and B equal to 1 and C equal to 0 and D equal to 1. You substitute here. So what value you will get? Suppose if you substitute what you are getting 0 plus A means what? 0 and 1. CRD is 0 plus 1. This is anyway what you are getting. This is 0 only you are getting. Okay. That is A equal to 0 means this is what? A equal to 0. Satisfied, no? Total Y equal to 0 you are
Yes, sir.
getting. Here this is A equal to 0. Satisfying.
Sir, so
Yes, sir.
simply we can design for this buffer only.
Buffer.
So simply
Hmm.
we can design it for buffer
Yeah,
only.
yeah, that's what I'm telling you. You can minimize this and you can design with a buffer. How you are designing the buffer? This is one inverter and one more CMOS gate is there. Here one more CMOS gate is there. Okay, this is PMOS and this is NMOS and this is connected like this ground and this is VDD and here you are taking the output Y equal to what? A. A. Okay.
Sir, I have another doubt. In some cases, we are using a inverter at output, no, sir. Why we use that?
That why you are using means here. Suppose, like, so we already implemented which gate? NOR gate. No?
Not this and
We
that.
implemented NOR gate and NAND gate. So what is NOR gate? NOR gate equal to ARB whole bar. Okay.
Okay.
NAND gate equal to what? AB whole bar. Okay. So if it is complement, directly we can implement with what? CMOS. Okay. Directly we can implement with CMOS. This is complement means we can implement with CMOS. Suppose if it is a Boolean equation, suppose you take A plus BC. Okay, A plus BC is nothing but one Boolean equation. So this Boolean equation is not in form of complement, no. So here what you need to do, you need to apply complement of complement. You need to apply complement of complement. From the not law, you know that A bar whole bar equal to what? A, no. So here what I am doing means, so this one like this one is there, no. This one I am implementing with what? CMOS, CMOS logic. Okay. Again, one more complement is there. No, this complement I'm implementing with which gate? Not gate. That only we already seen. No, last class. Last class we already seen. No, where mm, CMOS logic circuits. CMOS logic circuits. If you see CMOS logic circuits, yeah, I think it's not opening. We understood how I am doing. Hello.
Yes, sir.
Okay. So for that we are doing this. Okay. Is it fine? Shall I move forward?
Yes, sir.
Okay. So now we'll see this how to design this sequential circuits by using the CMOS logic circuit. Operator, we already got it.
Yes, sir.
Okay. SR latch. We already discussed SR latch now. What is this SR latch? SR latch. Latch. Okay. SR latch. Using NOR gate. Using NOR gate. Okay. Implementing this SR latch using NOR gate. And I'm implementing with which logic means CMOS logic. I'm implementing this with CMOS logic. Okay. So SR latch, if you see the SR latch, so this is one SR, one NOR gate, and this is one more NOR gate. Okay, this is linear phase diagram. Okay, output will be feedback like this, and here also output output will be 1 second. Sudha, మా సుధా సాని పిలుస్తుంది. సాని పిలుస్తుంది. సుధా, ఏ సుధా ఎక్కడున్నావు? ఏమైంది సాన్వి? Just 2 minutes. Okay, stay online. ఏ సుధా ఎక్కడున్నావు? మమ్మీ సాని పిలుస్తుంది. ఏమమ్మా? Silence, silence. Yes, okay, okay. Yes, we want to implement this. I'm audible, no? Just to give reference so that I will move
Yes.
forward. See here, this is using target. So we already seen this is R and this is yes, okay. And this one is first gate and this is second gate, okay. So we already seen the truth table. What is the truth table? Yes, R and next Q bar. Okay, this is the next state, and the operation, or we can call as a state. Okay, we can call as a state. So here if you see 0 0 0 1 1 0 1 1. Okay, these are the possible combinations. So 0, 0 means what? Which state? This is nothing but memory state. Okay, let us take this is Qn plus 1 and Qn plus 1 bar. Okay, so memory state means we can write Qn. Okay, this is Qn bar. Okay, and next this is what? This is a reset state, set state, and this is not allowed means this is a invalid state. Okay, complement of this means this is 1 and this is 0 and this is invalid only. Okay, so what is the operation? We can call this is a memory state. This is memory state, reset state, and set state. Okay, invalid state. This is invalid state. Okay, so this we already see. Okay, so how to design this one? So how to design this one? So first, basically, we will design. This is VDD, and pull up. So pull up network as what? Pull up network as PMOS, and pull down network as what? Pull down network as NMOS. Pull down network. So whatever the pull down network is there, that is NMOS. Okay, and this is ground or VSS. Okay, this is ground, and here you are giving some inputs. Okay, and here also you are giving the inputs, and you are taking the output from here. Okay, so that means here plus. So plus means what? Plus means PMOS will be in series. PMOS will be in a series, and NMOS will be what? NMOS will be in parallel. Okay, NMOS will be in parallel. Okay, first what you need to do? You need to design two CMOS circuits. We realized by using CMOS circuits, no? NOR gate by using CMOS circuits. We realized the NOR gate by using CMOS circuits. Like that, you realize two NOR gates by using CMOS circuit. Okay, so here if you see, this is VDD. Okay, this is VDD. Plus means what? PMOS will be in series. PMOS will be in series. Okay, PMOS will be in series. And here NMOS will be in parallel. NMOS will be in parallel. Here NMOS will be in parallel. So this is connected to ground. This is connected to ground. And here this and this is connected together, and this is nothing but R. And this is connected together. This is nothing but this is one more. So if you see, this is nothing but this signal, this R. Okay, and this one will see. Okay, here also you connect one more NOR gate by using CMOS. So VDD, and PMOS is in series. This is a plus operator, OR operator. So this is in series. And next, here this one will be parallel. Oh, sorry, this is a NMOS, no? This is NMOS. This is NMOS, and this is parallel, and this is connected to VSSR ground. VSSR ground, and here how to connect here this one. Okay, so here these both are connected like this. These both are connected. Okay, and these both are connected. Both are connected, and this is my S. Okay, this is my S. Okay, and here, so this is my R and S. This is my R and S. Okay, this input will be feedback to this input. This output will be feedback to this input, no, and this output will be feedback to this input. Okay, so I am doing this connection. Okay, so here what is the output? This is the output, no. Okay, this is the output. So this output I need to connect to this input. So this is my output. This output I need to connect to this input. Okay, and this output. Okay, so this output, this input. Okay, this input is connected to this output. This input is connected to this output. Did you understood how I am drawing this? This is nothing but SR latch. SR latch. I need to draw two NOR gates by using CMOS. After that, so this is anyway R and S. Okay, so this is my R and S, and output will be feedback. No, output will be feedback. So how am I connecting this out? So here this is R. Okay, this is my R. Okay, this is my NOR gate 1, and this is my NOR gate 2. So for NOR gate 1, R is the one input, and next this output. Okay, this output. Which output? This output. Other NOR gate output is connected as this input. Okay, this is nothing but input, and this is nothing but output. Okay, so this one is over. And next, for this second gate, if you see, what is one more input? S is the input, and after that, uh, this output is connected to this input. Okay, so that means this is the second gate, this is the input. For second gate, this is the input, and for first gate, this is the output. Okay, so output of second gate is connected as a one second. Yes, no. Yes, yes means mm. So input of second gate is connected to the output of first gate. Input of second gate is connected as the output of the first gate. Like this we need to connect. Is it clear? Do you understand?
Sir, number of PMOS in both S and R are
Hmm.
different.
Number of PMOS in S and R. This is a NMOS only. This is NMOS only. This is NMOS only. This is NMOS. Okay, pull down
Yes,
networks are what? NMOS. And this is PMOS. This is PMOS. Okay, here also. These pull up networks are PMOS, and pull down networks are NMOS. Now you understood how many PMOS and how many NMOS are required? 4 PMOS and 4 NMOS are required. Done? Hello?
yes, sir.
Okay, okay. Like this, you need to design. Okay. Uh, so this is nothing but CMOS. CMOS. No. Your task is design CMOS SR latch, SR latch using using NAND gate. Using NAND gate. Okay, this is your task. Okay, so take this as a reference and do this task. Okay, you need to design CMOS by using NAND gate. Okay, using NAND gate. Okay, suppose I want to design CMOS D latch. Okay, so CMOS D latch means how we can design CMOS D latch. Okay, CMOS D latch. This one you can do, no? Any doubt or any query in this? CMOS SR latch by using NAND gate. NAND gate we already designed, no?
Yes,
So
sir.
that connected back to back, that is nothing but CMOS SR. So like this, first you draw the diagram. Okay, NAND gate. Okay, this is NAND gate connected back to back. Okay, and you design this by using CMOS, this by using CMOS. Based on this, here you will get S and you will get R. Okay, and this is Qn and Qn bar present state. Next state is Qn plus 1 and Qn plus 1 bar. Okay, hope you can do. I think so. Okay.
Yes.
Okay. Next, CMOS deluxe. Okay, what is deluxe? Deluxe means here this is a delatch. Delatch. What are the inputs? D input and Q and Q bar. Q and Q bar. Okay, enable pin will be there. One enable pin will be there. Okay. So what is this operation when enable equal to 1? Enable equal to 1, qn plus 1 equal to qn plus 1 equal to d in. Okay, d in. When if enable equal to 0, okay, it will be in which state? It will be in the previous state. What is the previous state? queue, or memory state or previous state. Okay, queue. Okay, so you will design this D latch. It means but the SR latch will get the D latch. We already see that. Okay, so that means so this is SR latch by using NOR gate. This is SR latch by using NOR gate. So output will be feedback like this. Here also this will be feedback like this. Okay. And here you need to connect one which gate means NAND gate. NAND gate. Okay. This here we need to connect one NAND gate. Gated latches we already see now. This is nothing but gated latches. Okay. So here this is the input. Input is connected through the inverter. Input is connected through the inverter. Here you are giving D input. You are giving D input, and this is enable. This is what enable. Okay. Let us take enable. Okay. And here what you are getting. This is D in, and this is D in bar. Okay. D in bar, and next here what you are getting.
ఉంది ఏముంటే ఏమైతుంది ఏది చదవాలా అని
Suppose it is considered as so let us take this is AND gate only. Okay, this is AND gate only.
నాకేం అర్థం కాలేదు అల్ల అసలు
This is NAND gate. Okay, okay, this is NAND gate. Okay,
అవును ఎందుకట్లా
Shivani, mute yourself. Enable into DN bar. Okay, this is enable into DN bar. This is nothing but enable into DN. Okay, enable into DN. Okay, so what is Q? Q equal to you are getting enable into DN bar plus uh, this is Q bar. Okay, Q bar. Okay, so this will be feedback. So this will be Q bar. No, this Q bar is one input. Q bar whole bar. Okay, and next state. What is this? This is next state. Qn plus one. Okay, so Qn is the present state. Okay, Q. Let us take Q bar is the present state. Okay, so here what is Qn plus one bar? Qn plus one bar equal to we are getting a D in bar. Okay. This is D in bar. Okay, D in bar, E into D in bar. We are getting E into D in bar. Okay, E into D in bar plus Q bar. And here you are getting D in bar, E into D in plus Q whole bar. Q whole bar. Okay. So you got these two equations, that is Q and Q bar. So you know that if it is a AND operation, PMOS will be parallel, PMOS will be parallel, and NMOS will be what? NMOS will be series. Okay, NMOS will be series. Okay, and if it is R operation, PMOS will be what? PMOS will be series, and NMOS will be parallel. Okay, NMOS will be parallel. So with this equation, can I draw the CMOS circuit? With this equation, can I draw the CMOS circuit? Tell me. Okay, I will draw the CMOS circuit. Okay, so here Dn equal to what you got? So this is let us take Q. Okay, Q equal to what? E into Dn bar, E into Dn bar plus Q bar whole bar. Okay, and Q bar equal to what? E into Dn plus Q whole bar. Okay, Q whole bar. So this one I need to implement with CMOS. Okay, so yes, so uh, so this one for Q and Q bar. First Q bar I'm implementing. Okay, Q bar I'm implementing. Okay, for Q bar, see here. E into Dn. E into Dn means what? So this is AND gate. AND gate means here this is VDD, and here these two are in parallel. PMOS will be in parallel. PMOS will be in parallel. Okay. So one input is what? DN. One input is DN. Another input is enable. Another input is enable. And these two are connected parallelly. And this one is connected with series. Okay. What is that series? Series means what? Q. Okay. Q. So this is a Q. Okay. Let us take this is Q. Okay. And next here, here you are getting what the output is. This output is what? Q bar. This output is Q bar. Okay. And next if you see, uh, so next, yeah, next,
So the
if you take the PMOS, okay. So if you take the NMOS, this is so Q bar. This is the AND operation. So AND operation means what? These two are in series. These two are in series.
thing
Okay, series. Okay. So this is what? This is D in,
A
and what is this? Enable. No, this is enable. Okay, these two are in series, and parallel with what? Parallel with Q.
Q
Parallel with Q. Okay, so parallel with Q. Okay, this is Q. This is my Q. Okay, parallel operation. So yeah, so this is parallel operation. This is my parallel operation. Okay, so I drawn for what? Q bar. Okay,
Q
next I need to draw for what? Q. Okay, based on this expression, I need to draw for Q. So this is VDD, and so one input is what? One input is so this one is AND operation. So PMOS will be in parallel. So let us take this one is enable pin. This is enable pin. These both are connected. Okay, these both are connected like this, and this pin is what? Enable pin. Okay, enable pin, and next this one is PMOS. This one is PMOS, and this input is what? D in bar. This input is D in bar. Okay. And next these two are connected, and
C
and series with
Q and
Q bar.
bar
Series with Q bar. Okay.
Q bar.
Series with Q bar. Series with Q bar. Okay. This is Q bar. Hmm. Okay. And next,
So the
this is my
Q
Q. No. This is my Q. This output is my Q. Okay. And below this, you need to connect. Need to connect. Tell me. Mm, Q bar,
A and D in
you are writing Q bar. Here
series
you are getting what? Q bar. Here you are getting Q bar.
Q
This is
A
NMOS. And these two are in series, no? D in bar, D in bar. This is
and
D in bar,
A
D in bar, and
and A.
E enable. D in bar and enable. Okay. So this is enable. Enable and connected like this. Connected like this. Okay. And now, so what are connected? So, so Q, so this one is QQ are
Q
connected. Okay, QQ are connected like this. So this one QQ are connected like this. Okay, here what are connected? Q bar and Q bar are connected. This Q
bar
bar and this is one Q bar. This is one Q bar. Okay, and this output. Okay, this output is connected to this input. This is the output. No, this output is connected to this input. Similarly, this input is connected to the this output. Did you understood how I am drawing? Did you understood? Means this is the output. This is Q. Okay. So here This is output. This is my output Q. Okay. This is my output. This is my output Q. Okay. Why? Because here what happens? This will be like feedback. No. This feedback.
Yes.
This feedback I'm connecting like this. This feedback I'm connecting. That means this output Q is connected as the input. Q is connected as a input. Okay. And this Q bar is connected as a input. Okay. This output I am connecting as a input, and this output I am connecting as a input. Okay. See here, Q bar connected. So Q bar. So where is Q bar? This is Q bar, and this is also what? Q bar. Okay. So this is the output. I am connecting to the what? Input. Okay. And this is what? This is my Q. Okay, this is my Q. This is what? This is the input of this whole thing. I'm connecting to what? Output. I'm connecting to. Is it fine? Do you understood how I'm doing?
Yes.
Okay. Okay. So like that, task two, task two, task two. We need to design CMOS SR latch, not SR latch, SR. What I call DFlipFlop, DFlipFlop. Okay. Okay, I will tell you the essential flip using another gate. You do CMOS gate flip-flop. Okay, I will tell you the SR flip-flop. Okay, what is the difference between flop and latch? What is the difference between flop and latch? Anyone? Your response. What is the difference between latch and flip-flop? Latch is what? Level trigger. Level trigger. I told you no. In the discal, I
Yes.
told you. Okay, either positive level trigger or negative level trigger. Okay, latch is a level trigger, whereas flip flop is nothing but what? Edge trigger. Flip flop is edge trigger. Okay, flip flop is edge trigger. Okay, that means again these are positive edge trigger, and negative edge trigger. Negative edge trigger. So positive. So level trigger means what? During this level, the output will change. Positive level. Okay, this is positive level, and the negative level means during this negative level, the output will change. Level. Okay, during this level, the output will change. Edge means what? During when it is going from uh, like uh, like edge, when it is going from 0 to 1, then it is a positive edge trigger, and when it is going from this is positive edge trigger, and when it is going from 1 to 0, 1 to 0, this is what? Negative edge trigger. This is negative edge trigger. That only I told you, no, latch and flip flop. You have a clock. Okay,
Yes.
you have a clock. That way I told you. Okay, and so I will design the CMOS SR latch using the NOR gate. Okay, CMOS SR latch using NOR gate. SR flip flop, not latch. Latch we completed. SR flip flop, SR flip flop using SR flip flop using NOR gate. Okay, NOR gate using NOR gate. Okay, so if you see, so how you are designing, I think same thing we can design. So here you see. So how you are designing means here first you draw the NOR latch, NOR latch. This is NOR latch. Okay, this is NOR latch. The output will be feedback to input, and here output will be feedback to the input. And here you are giving a AND gate, and here also you are giving an AND gate. Okay, and this one is what? R, and this one is S, and these both are connected with what? Clock. These both are connected with clock. So clocks are two types. Now, if you are giving directly means positive trigger, and you are giving through the bubble means what? Negative edge trigger. Okay, so negative edge trigger. So here, what is the output? This is Q and this is Q bar. Okay. Let us take this is R star. R star. Okay. R star equal to what? R star equal to we are getting R into clock. R and clock. Okay. And S star equal to what? S star equal to you are getting S and clock. Yes, and a clock. Okay. And if you want to write the expression for output, so Q equal to what? This will be feedback. This is Q bar, and this is what Q. Okay. So what you are getting R and clock plus R operation plus Q bar, whole bar. Okay. Q bar equal to what? S and clock, S and clock plus
That's true.
plus q whole bar plus
Hold
q whole bar. Okay, so that means you can do the functionality clock yes or clock yes or. So this is what q bar and operation operation. Okay, so if clock is equal to 0, whatever may be the S and R value, what you are getting, this is nothing but memory state, no? So this is nothing but we call as, let us take this is, next state is Qn plus 1. Okay, next state is Qn plus 1. You are getting in Qn and Qn bar. What is the state? Memory state. Okay, and when clock equal to 1 only, this will be operated. Okay, how many possible combinations? 4 possible combinations. 0, 0 means what? 0, 0 means memory state. Okay, Qn bar. So 0, 0 means memory state. Okay, 0, 1 means what? Reset state. Okay, reset state. This is 0 and this is 1. Okay, reset state. And 1, 0 means set state. 1 and 0. This is set state. Okay, 1, 1 means what? 1, 1 means uh, this is invalid state. Invalid state. Okay, so this is invalid state. Okay, so this is my operation, and based on this, I need to draw the circuit. Okay, so one more time, I'm writing this expression. What is my expression? So here I'm writing. Okay, so for flexibility, I'm writing. What is this? Q equal to what? Q equal to R and clock plus Q bar. Okay, this is one more expression. And Q bar equal to what? Q bar equal to S and clock plus Q. If this operation is fine now, we already seen in the digital.
yes.
Okay, we already seen in the digital, no? SR flip-flop,
Yes, sir.
SR
Yes, sir.
flip-flop. Okay, so you can go through that. Okay, so if you see this, I want to evaluate this. Okay, so here if you see, first I am evaluating for what also. First I am evaluating for Q. Okay, so Q means so we for and operation, PMOS will be what? Parallel,
Correct.
and NMOS will be
Series.
series. NMOS will be series. Okay, and for R operation,
Series.
PMOS will be series, and NMOS will be parallel. NMOS will be parallel. Okay, NMOS will be parallel. So here I'm drawing this circuit. So what is this? This is VDD. VDD. Okay. Yes. So first what I'm drawing means for Q bar I'm drawing. Okay. So Q bar. So this is AND operation. This is AND operation means what? Yeah, these are two are in parallel. PMOS, these two are in parallel. Okay. So this one is yes. This one is yes, and this one is clock. This one is clock. Okay. And these two are connected like this. Plus Q. Plus Q means what? This is series. This is series. Okay. Series. Okay. PMOS, pull-up network. And coming to the NMOS. Okay. Coming to the NMOS. So here S and Q means what? These two are in series. These two are in series. Okay. So this is S and this is clock, clock, and parallel with Q. Parallel with Q. Okay. So here you'll get like this. Okay, this is the output. Okay, this is my what? This is the Q bar. Okay, so this is my output. What is this Q bar? This is Q bar. Okay, so what are the inputs? This is yes. This is Q. Okay, this is also Q. Okay, and next I'm drawing for here. I'm drawing for what? This one Q. Okay, VDD, VDD, and next here this is R.
R.
Okay,
Okay.
for flexibility here I'm drawing clock. Okay, clock is common. No, I'm connecting
Yes,
like
sir.
this and I'm giving clock. I'm giving clock, and this side I'm giving this is R, no? This is
R.
R. R. So this is R. These two are in parallel. And next, series with Q bar. Okay. Series with Q bar. So this is Q bar. This is Q bar. Okay. So this is Q bar, and this is R. R. So PMOS is out. Okay. And NMOS, if you see. So NMOS, so R and clock, these are in series.
Yes.
R and clock and operation. These are in series. Okay. So these are in series. So these are in series and Q bar. So Q bar is R operation. These are in parallel. These are in parallel. Okay. So these are in parallel and this is connected to VDD. Okay. Or VSS. Okay. VDD or VSS. What is this? This is Q bar. This is Q bar. Q bar. And this is R. And this is clock. Okay. Now how I should connect the so input. So what is the input?
What is Q?
Uh, so input is QQ. These two. This is nothing but input. No, this is nothing but input. Okay. So this one and this one. This is nothing but input. Okay, for this. And Q bar. This is input. Okay, input. Okay. This is my input. So here Q bar is connected. So Q bar is connected to the where you have to connect input. This input Q bar. This output. Okay. So basically this is output. Okay, and this is let us take input. Okay. So this Q bar should be connected to this input. Q bar should be connected to this input. Okay, and this is one more input. This input. Okay, this is my input. Okay, input. This is Q. Okay, so Q is connected to this output. To this output. Okay, so this is output. Same thing, no? So we already seen, no? Here, this one,
Yes.
okay, this Q bar is connected as a input. This Q bar is connected as a input, okay, and this Q is connected, output is connected to the input. Output is
Input.
connected to the input. This same diagram I drawn here. So Q bar. So this is output is connected to this input. So this is nothing but Q bar. Okay. And this is Q. Q is connected to what output. This is nothing but Q. Q connected and Q bar connected. Like this. Did you understood?
Yes, sir.
Okay. So your task is you need to task two. So task two is you need to design CMOS JK flip flop. CMOS JK flip-flop using NOR gate. Using which gate? NOR gate. Okay. What is task one? Task one is you need to design what
R.
CMOS SR latch using NAND gate. Task two is you need to design CMOS JK flip-flop
JK.
using NOR gate.
Okay.
Okay. So with this, we completed the realization of this combinational circuits, realization of universal gates, AND gate, NOR gate, realization of Boolean expressions, and realization of combinational circuits, and realization of these sequential circuits. Those are latches and flip-flops by using CMOS circuits. Okay. Is there any doubt or any query in this session or this CMOS circuits?
No.
Okay. Okay then. Okay. So come up with the task and we'll discuss. Next we'll start the sheet diagram. Okay.
Okay,
Sheet
sir.
diagrams will start. Okay. Okay. If you don't have any doubt, you can leave the meeting. Okay.